Hi, Susan Holloway here, and today we are going to look at a couple of functions of a GeoGebra tool that I created. And this is in order to work with several math functions and understand them better. And I found that when you're becoming familiar with a new math function, it's often helpful to view the concept in terms of a parent function and the transformations that can be applied to that function. This is especially true in Algebra 2 when a number of functions are introduced. One way to understand functions better is to utilize graphing calculators and graph each equation one by one as transformations are applied to them. But here, I'm going to use this GeoGebra tool to demonstrate parent functions and then to compare them to many possibilities for transformations. In this video, we'll explore the first three types of functions that this GeoGebra tool is able to illustrate. Those functions are linear and polynomial functions, inverse functions, and radical functions. This tool can also show how exponential functions and logarithmic functions are transformed, but these functions will be explored in another video. First, let's take a look at linear functions by clicking on the y equals x box. And here we see that the equation for a line in the slope-intercept form can be illustrated by moving the intercept point up and down and by changing the slope from 1 into the positive range and into the negative range. Now we can add all polynomial functions by simply changing the exponent. Here, n is equal to 1. However, with n equal to 2, we see that this function illustrates the vertex form of the polynomial functions. So as I change the exponent from 2 to 3 to 4 to 5 to 6, one thing to note is how the graph is symmetric with even exponents, but not so along the y-axis for odd exponents. So the left-hand side is a reflection over the x-axis, but not over the y-axis. Now we see what used to be the slope in linear functions, and now I know that the Prentice Hall textbook calls it a stretch factor. As it becomes less than 0, the function is very wide. I'm sorry, less than 1, and less than 0, then the parabola or quadric points down. Here, the vertex is moved up and down. in the xy plane. For inverse functions or reciprocal functions, it's interesting to look at, I think it's interesting to look at whether or not there is a vertex and what that vertex, how that vertex is moved around on the graph. So let's take a look at some of these functions. First of all, with a reciprocal function, the parent function would be considered 1 over x. And if you draw the function 1 over x, this you see that the asymptote is at x, and there's also an asymptote at the y-axis. If m becomes negative or positive, you see that that the function is reflected over the x-axis and into a different quadrant. Changing h changes where the asymptote lies. And changing v also changes where the horizontal asymptote lies. In radical functions, it's interesting to see how the square root function moves both vertically and horizontally. Not only the square root function, but other rational functions as well. When the root is odd, the function exists in both negative and positive. When the root is an even root, the function only exists in one quadrant. So there are a lot of different ways to explore functions with transformations in GeoGebra, and this tool makes it very easy to look at the different transformations and to understand what different parts of the function do. You can find this tool in the GeoGebra Tube store.